All right. So now what we're going to do is we're going to kind of take a graphical look at this, and we're going to look at general cases of this. And to do this, we're going to do what we've been doing for a while now, which is we're going to use Desmos. Yeah, and we'll go from there. And we're not going to get too crazy on the algebraic side of things in this lesson. We will in the next one. We'll go a little deeper on that, but for right now, we're kind of doing concept development here. I want you guys to just sort of see how we get started with this and what happens as a result of this, and why inverse. Why, Mr. Simons? Why? Well, hopefully we'll be able to sort of answer that. Okay. So what it says here is to graph the inverse of a function. Right. Let me get off. I don't know why it's doing that. It says simply blank x and y in the equation, and let Desmos handle the rest. So what we are going to do, and what I want you to write down if you're following along with this, is I want you to write down the word switch. You're going to switch. And we were kind of hinting at that in the first video, right? An inversion table switches your normal position. Normally, when you when you stand, right, your head is on top and your feet are on the bottom. You know, your head is facing the sky and your feet is facing the earth, right? And when you're on an inversion table, it kind of flips you upside down. So your feet are facing the sky and your head is facing the earth. So that's what we want to think about. We want to think about the word switch, all right? And so it says we will write an equation for the inverse of each function below, then use Desmos to graph the function and its inverse on the same set of axes. Sketch what you see. So when we do these, we're not going to go too crazy, and I'm not going to ask you to do anything too mental with this, because we're going to let Desmos kind of do the main part of the work, and it will. All right, so here's the function, and we're gonna not use f of x notation for this. Even though we're talking about functions, we're gonna use y, because you can't, putting f of x back in gets kind of problematic. All right, so we're gonna use y. So our inverse function is you literally are just going to take y and x, and you're going to switch places with them. So you're gonna put here. Let me change that really quick. We are going to take we're going to take y. We're going to move it where x is. And then we're going to take x and we're going to move it where y is, right? And so when we write our new equation, we're going to have x equals 2y minus 5. Now notice when I switched that, I did not take the coefficient with x, because we're just concerned about x and y. We're not concerned about anything multiplying them, adding to them, any of that. Just the variable itself, and only the variable. So now we switch this out, and this is my inverse function. Okay, my inverse function is x equals 2y to the negative fifth. All right, so now what we're going to do is we are going to open up Desmos. Okay, and I do have it opened here. Let me make sure we're still going strong here. All right, and here's Desmos. All right, so I'm going to go in here, and we're going to type it in. So the first thing I will type in is the y equals 2x, and then what was it, minus 5? Can't remember, got to check. Yep, it was 2x minus 5, all right? And so now let's look at this, and this is what we get, right? We get y equals 2x minus 5, okay? And now we are going to switch it with this inverse, and I'm going to write x equals 2y minus 5. And then look what we have here, right? So what we've got is we've got this line that they both got positive slopes, but it looks like they meet here, right? And they kind of, you know, if I were a betting man, I'd be like, you know, it kind of looks like there's a little bit of a reflection going on here, right? It maybe, you know, something along here. Not sure. All right. So now I'll get this set up for the next one, and we'll jump and do this again. So this is our main function, is y equals negative 3x plus 1. So let's go and put that in. All right, so y equals negative 3x plus 1. So that's red. All right, this is my red function right here. Y equals negative 3x plus 1. Now we're gonna rewrite it. Okay, so when we rewrite the inverse of it, we just swap x and y. Okay, so this becomes x equals negative 3y plus 1. I'm going to take this and kind of clean up whatever was happening there. I was touching the tablet pad. All right, so x equals negative 3y plus 1. Let's write that down. X equals negative 3y plus 1. Okay, and we're gonna toggle these first two off. So this is what we have. So this is our original function right here. Okay, and this is my new function here. And so this one kind of looks like it has a bit of a reflection thing going on too. Like you can sort of draw a line down here and see where that's sort of reflecting. You can also do the same thing. You think there may be a reflection line going somewhere along here, right? Where they're kind of the opposite of each other, right? So very interesting. Now let's do this one last time. So if our function is y equals 1/4 x to the third, okay, this is going to be, this is a cubic function, so this thing's going to have some action going on with this. So we got 1/4, and we got x to the third power. All right, and let's toggle off these other two. All right, so this is my function here. Now, if this kind of holds true with the linear functions, right, there's going to be some sort of a reflection going on. We don't know what that's going to look like, but there should be something, because the shape of the function itself is has so far sort of been the same, right? It's just been kind of moved and maybe flipped. So we'll see. So let's see if that's the case. So we got x equals 1/4 y to the third. All right, so now let's put this thing in. Okay, so 1/4 y to the third. So we go x equals 1/4 and y to the third. And you know what? It is kind of the same shape. It just looks like it rotated, right? It rotated 90 degrees. Well, actually, no, it rotated more than 90 degrees. It looks like it kind of flipped and it rotated. You take this thing and kind of flip it around that way and then rotate it 90 degrees this way. That looks like what we got. And you can see we can kind of draw a line of reflection sort of along here, right? And we could draw one like here, okay? So that's kind of a hint as to what's happening here. So let's put all of these up here. You can sort of see them. So those are two, right? And then we got these two right here. And so you can sort of see what's happening. So what we're going to do is I'm going to stop the video here, and then in the last video I'm going to talk about these. And then we're going to try and answer these last questions and see exactly what's going on here. All right, so be back soon.